Hexcorder Pro utilizes a ruggedized Android tablet as the user interface and runs on an Android app. The beauty of this is anytime you're connected to Wi-Fi, the app will automatically update to the latest and greatest version, no charge. The app language is linked to the language settings on the tablet, so it can run in many different languages. The instrument performs CIPS and DCVG ECDA surveys, requires no special software, and is GPS synchronized with current interrupters and other stationary data loggers. It will record to memory the GPS coordinates for every reading and will store depth of cover data streamed from Bluetooth-enabled pipe locators. The Hexcorder Pro has 2 CIPS channels and 4 DCVG channels. It offers a resolution of 0.1 millivolt, AC rejection of up to 90 decibels, and a 25 or 250 megohm input impedance for arid soil conditions. It has a lithium-ion battery, and communications are via USB or Bluetooth. It has an integrated GPS and can be upgraded to sub-meter or sub-decimeter accuracy upon request. The tablet is a ruggedized mil-spec tablet selected for its excellent daylight readability and long battery life. The Hexcorder Pro is offered as a complete kit with the choice of hip pack or backpack wire dispenser chainage counter assembly. It comes complete with everything required to start a survey. The instrument uses the 2 CIPS channels and 4 DCVG channels in a combination of inputs to generate 10 possible ECDA survey combinations to suit various field conditions. CIPS measures cathodic protection, and DCVG identifies coating defects. They're 2 halves of the same equation in pipeline integrity management programs that allow owners and operators to prioritize where their remediation is focused. It's quite possible to have a major coating defect that, if cathodically protected, would be a lower priority item than a small coating defect that's below cathodic protection criterion. The benefits of a combined survey are that you gather all the data at the same time under the same field conditions into a single file, so the different data streams are already correlated, and you only mobilize a survey crew once. Here we see a typical survey with the CIPS data at the top showing the on and off readings, and DCVG along the bottom in pink. The defect at chainage 3770 needs repairs, as the pipe to soil potential is below criterion, but the defect at 3950 is still well protected. If you only want to do CIPS on multiple lines in a common right-of-way, that's also possible if they're electrically connected. The 4 DCVG channels can be utilized in complex piping situations to determine if defects are on the pipe in concern or the pipe beside it. The Android graphics allow us to simulate a bird's eye or hard hat view of the survey team showing the current flow. Double DCVG survey mode can take readings from center to left and center to right, so it's very useful in common right-of-way situations to see if the defect is on the pipe in concern or another pipe nearby. CIPS with double DCVG is excellent for gathering details on both sides of the pipe, but it does require additional manpower. So again, the data plots in Excel and shows the CIPS data on the top with the 2 sets of DCVG data below. The defect at chainage 840 may warrant investigation. Double impedance CIPS is a unique survey mode aimed mainly at arid soil conditions where we measure the pipe to soil potential twice for each on and off, once at 25 megohms and once at 250 megohms to calculate a true potential in poor soil conditions. Double impedance CIPS can also be combined with DCVG. The CSV file header details contain all the setup parameters for future reference, so there's never any question about how the survey was configured. The data file outputs as CSV and records date, time, GPS coordinates, CIPS and DCVG data, depth of cover data, and comments for each reading. This is what the home screen of the app looks like, and it's very user-friendly. It's all touchscreen, drag and drop, or toggle on and off. We'll have a closer look at each of these modules. Just for fun, here's what the home screen looks like when the Android tablet is set to Chinese, or in this case, Spanish, or even Turkish. If we haven't done the translation yet for your language, we can. There are 6 main tabs for the survey settings, so we'll have a look at each of these in closer details. So if we tap the Survey Settings tab, it will bring up this screen. You can enter the name of the surveyor for future reference. You can give the survey a meaningful title that engineering will recognize. You can select one of the 10 possible survey configurations. You can select whether or not to run in GPS synchronized or not. These days, most surveys are GPS synchronized. You can record data in imperial or in metric. You can select the method to trigger readings, either manually or based on distance or on time. You can program in the starting chainage to match the line you're on, and can set this for increasing or decreasing depending on if you're surveying upstream or downstream. On the parameters screen, you can choose between 25 or 250 megohm input impedance. You can select 50 or 60 Hertz for the active onboard AC filtering. You can enable or disable a number of the various alarm functions, set alarm thresholds. You can decide to show the GPS coordinates on the survey screen in real time or not, and program in a local UTC offset so data is recorded in local time. On the Cycle and Timing Settings tab, we configure the survey instrument to match the current interrupters. Here we enter the total cycle time and the auth time. The Hexcorder Pro will automatically insert appropriate delays into the reading times to ensure it looks for the right details at the right moment in time. You can also decide whether to start the interruption cycle with the on or the off to match whatever brand interrupters you might be using. They're not all the same. We present the survey data to the operator in 5 possible views: as a digital table, as a graph, or can show position on a map in real time, can simulate old school analog DCVG meter needles, and display a bird's eye or hard hat view of the survey team for use in DCVG. These can be switched up on the fly by the operator without stopping the survey. On the map settings, you highlight an area on the map where you'll be surveying, and you cache that to memory in the tablet for use in the field when there's no service available. KML files can be imported so you can follow a previous route. It will plot the surveyor's current position and path, and you can zoom in and out just like any map app. Once you have everything set up the way you need, the final Settings Overview tab shows everything in one place as a summary for your confirmation. If you're happy with the settings, simply tap Save Settings and then tap Survey. This will take you to the survey screen. Here we see the table on the left and graph on the right. The graph on the right has pinch zoom functions so the operator can zoom in on an area of the graph if they see something odd in the field in real time. The table shows CIPS data and left and right DCVG data with their on and off values. But in DCVG, we really care about the difference between the on and off. So if you tap Calculated Gradients, it will do the math for you on the fly in real time. Here we see the difference displayed on the fly in real time, reading by reading. There's also the provision for calibrating differences between half cells by tapping the half cell offset button. By tapping 0, you can eliminate slight variables between the half cells. In the main survey screen, the operator can change the way the data is displayed by tapping on the Survey Layout tab. This will bring up the 5 different display widgets, where the operator can modify the survey screen display as desired by simply dragging and dropping any 2 widgets to the main area. This can be done on the fly in the field without needing to start a new survey file. It doesn't change any of the survey setup or parameters, only what the surveyor actually sees. Here we see a bird's eye view of 4-way DCVG along with the map displayed. Here we see the table of values along with the analog DCVG needles. The survey is showing both left and right DCVG, so that's why the two sets of needles. Unlike traditional center zero stylus meters, where the operator had to constantly be watching to see how much the needle is moving, we show the on and off as a high and low needle, and suddenly it becomes obvious to the operator how large a gradient is simply by the spread between the needles. The meters are also auto-scaling, so you'll notice the one is plus or minus 25 millivolts and the other is plus or minus 50 millivolts. By tapping the Comments button, the operator can enter a comment attached to any reading if they need to make notes in the data stream. This will bring up a keyboard to enter comments along with a library of preloaded common comments that can be edited so you can build your own custom comments library. Depth of cover data can be streamed to the unit by suitably equipped pipe locators and is stored in the CSV file. By tapping the AC Scope Mode button, the Hexcorder Pro can also measure and record waveforms. These should be saved to memory in the tablet for future reference in diagnosing interference issues, etc. DC waveforms can also be captured to verify synchronous interruptions. There are numerous benefits to collecting and storing waveforms for future reference, as they can help confirm rectifier interruption synchronization, confirm delay times are appropriate for eliminating inductance and capacitance spikes, troubleshooting strange readings, calculating the magnitude of AC, and evaluating rectifier filtration. There's an excellent published article on this topic by Miss Elizabeth Nicholson, our General Manager, that is available online or at our website. In conclusion, I would say we have strived to produce a user-friendly instrument that can be adapted to the various field scenarios encountered around the world. You already own any software that might be required, so contact us to get a demo version of the app you can try for yourself.